Find the limit. We have the limit as x approaches 1 for the function natural log 4x plus e to the x. Natural log is defined for positive values of x. For this particular example, e is also defined everywhere. It has an infinite domain. As x approaches 1, let me expand this a little bit, y'all. We can substitute 1 in directly for the x's, and our function will be well defined. Natural log of 4 plus e to the first, natural log of 4 plus e. If your problem by chance asks you to approximate, you would simply type this expression into your calculator and press equals. In the next series of limits, we're going to use the information given, which is the limit as x approaches c for some random function, and it'll have a value of 4. If you square your function, you're able to square your limit. So that will simply be 4 squared equals 16. Square roots, that's just a different form of exponents. That's actually a power of 1/2. We don't need to translate it. Our function value, we can take our limit value, which is 4, and we can take the square root of that value, which is 2. These are just to show some properties of limits. If you look in your e-text, there are properties given inside your e-text, and they're all given together if you want to look at a little more formal definition of your limit properties. This next example, the limit as x approaches c for 4 times our function, that can also be 4 times the limit of our function, which was 4. 4 times 4 is 16. And finally, the limit as x approaches c for our function raised to the 3/2 power, that's square root of our function cubed. We can take our limit of our function and also raise it to the 3/2 power. 4 to the 3/2 power, that's square root of 4 cubed, square root of 4 cubed. This property in red is how to translate back and forth from rational exponents to radical form. So long story short, square root of 4 is 2, cubed is 8. Find the limit of a function, use a simpler function when possible. The limit as x approaches -3. This function is not well defined at -3 because you have a 0 denominator. You also have a 0 numerator. If you factor this expression, x squared minus 9 factors as x plus 3 times x minus 3, we get a cancellation. So we're able to remove the expression that creates a 0 denominator. X minus 3 survives. As x approaches -3, we have -6 for our limit value. If we were to graph this function, there would be a hole in the graph at the point -3, -6. The limit as x approaches 3 in this function, let's factor the numerator and denominator. The denominator is that same difference of 2 squares. The numerator we factor, 7 plus -3 is 4. 7 times -3 is -21. The x minus 3's cancel, and so we don't have to worry about a 0 denominator. X plus 7 over x plus 3 survives. When we substitute 3 in for the x's, we get 10 on top, 6 on bottom. 10 over 6 reduces to 5/3. In this last limit for this particular slide, if we sub in 1, 1 plus 8 is 9, square root of 9 is 3, minus 3 is 0. Denominator is also 0. If we rationalize the numerator, we multiply the top and bottom of this fraction by what's called a conjugate. The sign separating your terms, you go opposite, so we'll need to use a plus sign, but everything else stays the same. So if we multiply by square root of x plus 8 plus 3, top and bottom, this blue fraction has nothing more than a value of 1. It just doesn't look like the number 1. When we FOIL out the top, we're left with x plus 8 minus 9. Don't worry about multiplying out the bottom. I'm going to leave those factors pushed together. Here's why. When you combine like terms on top, you're going to get x minus 1, which will cancel the original denominator, and that'll leave us with 1 over square root of x plus 8 plus 3. And now you can safely substitute 1 in for x, and that'll give us a value of 1/6. Find the limit of the function. Use a simpler function when possible. These basically, that property over here to the right side of your screen in blue, this is one of your properties given in your e-text. Please check that out. If you can create a fraction that has sine of an angle where the denominator matches the angle, those will need to be the same. As you're approaching 0, your value will be 1. In fact, in our very first video, we used a whole lot of x values that approached 0 from the left and the right, and we got our function value approaching 1. In this first limit, we have sine x over 3x. I'm going to factor the 3 out of the denominator, and that will pull a 1/3 out in front. The limit as x approaches 0 of sine x over x. This limit is 1 times 1/3 is 1/3. In our second example, our angle and denominator don't match, but we're going to create a match. Let's pull that 3 out of the denominator again, and that's this black 1/3. That'll leave us with the sine 4x over x. I need the denominator and the angle to match, so I'm going to multiply 4 into the bottom, but to keep it balanced out, I'm going to multiply 4 into the numerator. And that gives me 1/4, 1 times 4 is 4, so that gives me 4/3. Now that I've created a match for my angle and denominator, this limit goes to 1, 4/3 times 1, that's 4/3. Difference quotient, this is going to lead us into derivatives in the next chapter. This is called a difference quotient. You have a difference of two terms and a quotient. The original function will always go into the top right of the difference quotient. I've highlighted that in blue. The second point that's arbitrary on a function is when you pick a different x value. Delta x is the change in your x value. So if you were to go from an x equals 1 to an x equals 3, your delta x would be 2. That's the difference or change in your x values. Without the limit, this difference quotient is the slope of a secant line, which is a line that cuts through your graph at two specific points, and it'll give you the slope, the rise over run of that secant line. As you reduce the gap between the x values, we have a limit as the change in x approaching 0. If you move the second point back onto the first point, you create what's called a tangent line. This example is just simply to illustrate how to calculate a limit of a difference quotient. The hard part for all these is the lavender part. It's calculating your function with x plus delta x subbed in. Our original function is 4x minus 7, so you replace the x with x plus delta x, multiply through by 4, and we have our new function value. So when you look to the right of your screen, this lavender part, that's the upper left expression minus the original function is the upper right, all over delta x. So you replace the lavender and the blue with your original function and its second point modification. Distribute the negative sign. Combine like terms, you're going to get a lot of them to go away, and that's always good. The only term that survives in the numerator is 4 delta x. The delta x in the denominator will cancel it, leaving 4. If your original function is linear, your difference quotient will come out as 4.